Associate Professor in the Department of Computer Science and Engineering in Oakland College. Based MAC protocols. And have the quick review for multiple access or medium access control protocols. Single shared broadcast channel have the disadvantage of collision. So multiple shared via Ethernet, waveLAN, satellites. So you'll be having so many number of you'll be having a collision in that. So multiple access protocol, so distributed algorithm determines how nodes share the channel. It is determined when a node can transmit to broad classes channel partition, frequency division multiplex access, and code division multiplex access. Time division multiplex access, the time and frequency will be taken for 4 users. You'll be having the time is divided into so many number of nanoseconds. So frequency division is given. The code division multiplexes the same frequency and time, but it the channel partition. So how the nodes decide on time, frequency, or no? So how the nodes will decide whether I have to have TDMA, FDMA, or CDMA? That's assigned by the central coordinator. HFL 802.1 infrastructure mode, cellular networks, cable modem. So distributed consensus protocols. The nodes broadcast the time, frequency, or code they are going to use, and for how much duration it will take place. Done over a separate control channel, typically used in MANETs. Listen before transmit. When the node has packet to sends the channel. If it is busy, we have to wait for a random amount of time, then it will try. No prior coordination among nodes. All nodes use the same time, frequency, and code. 2 or more transmitting nodes. Collision. Random access MAC protocol specific how to recover from collision. So it has to wait for a random amount of time. So it will take exponential backup. Examples of random access MAC protocol: CSMA, carrier sense multiplexes, carrier sense multiplexes with collision avoidance, and then carrier sense multiplexes with A send to B, C cannot receive A, C wants to send to B, C sends as a medium. So C is collision, carrier sends fails. Collision at B, A cannot receive the collision, CD fails, collision reduction fails. A is hidden for C. So exposed terminals B send to A, C wants to send to another terminal, not A or B. C senses the carriers, find the medium in use, and has to wait. A is outside the radio frequency of C, therefore waiting is not necessary. C is exposed to 2.11 DC of operation, distributed coordination function. It uses special signaling packets. Receive RTS deferred, so clear to send should have been sent. So then request to send. Then receive CTS clear to send, defer until data should have been sent. If you don't receive CTS or acknowledgement, back off and try it all over again. Channel partitioning MAC protocols is share channel efficiently and fairly at high load, inefficient at low load, delay in a channel access, 1 bar n bandwidth allocated even if only one active node. It's random access MAC protocol, efficient at low load, single node can fully utilize channel, high load, collision overhead. Both of these type of protocols have been used in wireless network and wireless network and sensors depending. So what are the requirements of the MAC access and medium access control? The important requirements of MAC protocols: energy efficiency, collision avoidance, scalability and adaptability, latency, then variation in delay is nothing but latency, jitter. It's also a delay, fairness, throughput. Obviously, any network has to produce or has to give the maximum throughput, and bandwidth utilization should be lesser. Energy efficient operation. An event is very slow. Event rate is very slow. Radio idle mode. So radio transmitter or receiver mode. That's it. Typical. See the schematic. An event. It has a typical sense response application. The end user will be waiting for a long time. Radio Duty cycling, listening radio off. Something important happen, need to receive a packet, keep the radio long duration. Scenario, time uncertainty problem. A and B need to communicate, packet ready, and you have to B has A possible packet losses if sleep, listen, schedule of nodes do not intersect. Three broad approaches: synchronous, asynchronous, and hybrid. Synchronous S Mac, T Mac. Asynchronous B Mac, stem and wake up. A hybrid UB Mac. So the latency fairness, it will give a, so trade-off is in obviously in energy. So major components of S Mac. The periodic listen and sleep, so collision avoidance, overhearing avoidance, and sleeping. Coordinates, nodes coordinate on sleep schedule. So nodes periodically broadcast a schedule. No node tries to follow the existing schedule. So nodes on border of the two schedules follow both time synchronized duty cycling. No network idle. No network, not network wide, just within the. So collision or overhearing. So IEEE 801 use the request to send or clear to send exchange. Broadcast packets are sent without request to send or clear to send. Unicast packets are sent with a request to send or clear to send. Overhearing avoidance. Sleep. When some node in neighborhood is transmitting, use the information in the network allocation vector to decide the duration. Is given receiver. So for synchronization, we have to listen the sender 1, 2, 3. So in the synchronization, that period will be so carrier sends, then transmit the synchronization. For RTS, request to send, then request to send, that time the sender 1 doesn't communicate, sender 2 request to send, it got the clear to send. You can, if I got the permission from the receiver, you can send the data. So I'm free now. Sender 3 is request to send, the request to send, so got the clear to send. So it will be sending the data. After sending the data, it will goes to the. So how much I can pass, how long I pass, that is the how to do the transmission. Single packet versus fragmentation. Single packet, high cost of transmission, retransmission if only a few bits have been corrupted. Fragmentations, and then large control overhead. Request to send, clear to send for each fragment, longer delay. Solution, don't interleave different messages. Long message is fragmented and sent in burst. Then request to send or clear to send reserve medium for entire energy. Fairness. So obviously the energy has to be saved. It's wins and advantages. Periodically sleep reduces the energy consumption in ideal listening. Sleep during transmission of other nodes. Message passing reduces control packet overhead. Losses the huge overhead of keeping the nodes in synchronization continuously. One synchronization packet every 15 seconds. Sleep periods cannot be large as nodes will drift apart and will be out of synchronization, completely missing the protocol. So neutral, fairness as long as packets hog the channel. Message latency, there is a delay in the sending the message. TMAC, timeout MAC, enhanced S MAC by allowing the nodes to have adaptive duty cycles rather than fixed duty cycle. So it will be flexible. So even every node decides its own duty cycle based on its activation period. The activation event, firing of the periodic timer, then reception of any data on radio, sending packets, etc. has more latency than SMAC, but gives much better energy performance for a low rate. This is applicable only for low data applications. Having BMAC is with the CC. So the LPL check interval, if it is too small, it's an ideal in listening. If it's too larger preamble, longer check interval. Evaluation. So wins and loses, no control packet overhead, no request to send or clear to send or synchronization packet. It have arbitrary long sleep periods. Losses, worst case preamble size has to be used for every packet. Huge overhead because of overhearing. Then neutral, fairness as long as preambles hog the channel. Message latency. Stem, wake up frames. Instead of sending a long preamble, send multiple wake up frames containing destination addresses. So need not to be complete packets, but can be small frames. need not to be done on the same channel. It can done on a separate control channel. So no, need not be done in continuously. It can have a valid acknowledgement. Then predictive duty cycle framework predict the clock offset while when transmitting the packet at the runtime to use the right amount of preamble size or number of wake up frames instead of the worst case, maintaining just the right amount of synchronization is needed. Uncertainty driven duty cycling back rate adaptive time synchronization. So then will be combined with BMAC. BMAC will be having higher duty cycle, which yields to higher time uncertainty, which leads to longer preamble. So UMAC in fixed mode and as well as various mode, irrespective of the duty cycle, it uses RATs to predict the time uncertainty. Use preamble size of a time uncertainty by time. So here can do in CIEEE 802.51454. So low rate wireless personal area networks. It monitors and sensor automatic control, monitors diagnostics, separates game voice security. So conclusion: one fit all solution. The matter for all MAC protocol does not exist. Different MAC protocols will have different trade-offs in terms of throughput, latency, and energy consumption. So the broadly two classes of protocols: channel allotment and random access. The prime important factor is time uncertainty because the critical bottleneck in the design of MAC protocol for duty cycled networks. So possible question: explain in detail about contention based MAC protocols in wireless adhoc network.